Hello everyone and welcome back. Today we're going to be revising some Splunk because it is very useful for blue team SOC teams. I haven't used it in a while either, so it's going to take me a second to remember as well. I prepared two rooms from tryhackme, so let's get into it. The first room right here is the new hire old artifacts and the second one is Conti. So anyways, once we get going and once we start the machine as well as our attack box, we're gonna be able to connect to our Splunk instance. Right here is the information that we need, and the only thing that we need is the port right here. After that, we're going to have to investigate a website password viewer executed on the infected machine, and what is the name of the binary and the full path. Okay, so once the machine is started, I'm just going to type in what I have to. And right there, you're going to see a Splunk screen. You're not even going to have to log in, so that's great. Alright, after some time of waiting, it has loaded. And we can take a look at the settings. And right here, we're going to navigate to settings. And you can navigate to indexes. And right here, you're going to be able to see the indexes that you have already on this Splunk instance. Usually, you're going to search through main. This is the most common place to be looking at everything. And as you can see, we do have some logs right here. We're going to ignore the metrics, obviously, and the introspection. So anyways, let's go back to Splunk. And we're simply going to just specify that we're searching through the index main, and we're going to use quotes as well. And if I select 24 hours, I'm not going to be able to find anything. This is because the log is actually stored from before, and we're not searching the instance that is currently getting logs, so this is not going to be working. So all I'm going to do is I'm going to press all the time, and we're going to take a look at our first question, which is a web browser password viewer executed on this infected machine. So what is the name of the binary? Now for this, I actually thought about how I could approach this, and the simplest way that I could think about is web and password. And if I search that just right there, I'm going to be able to see the web password viewer. And if I take a look at all the lines, I'm able to see a little bit more information about the exe. And you can see that it's called 11111exe, and it is a web browser password viewer, and it is created by Nearsoft. And Nearsoft is usually known to create these small tools that help in hacking and system administration and whatnot. So let's take a look at our solutions. We can copy the whole thing right here. If you share the clipboard properly, it should work. So just copy it and just paste it right here. As you can see, mine pastes it as well. And I'm going to take a look at what is listed as a company name. And as I said, that's Nearsoft. So we're going to just write that right there. So then another suspicious binary is in the same folder, and it was also executed on the workstation. So what is the name of the binary? Oh, and also we have to list the original name as well as the new file name. So how are we going to do this? Well, we want to copy this path, and we're going to just paste it as without the keys with the web password, because it might not be the same right now. So we're just going to paste it right here. So all we have to do is we just have to add the escape character as well for each and every backslash. And right here, you're going to get the results, and you're going to see that there's a lot of exes, but it all looks like it's the same exe. So let's take a look if we can find any other interesting exes. So we could look through all of these individually, or we could just click image and we can take a look at what we have here from images. And as you can see right here, we have an easycalc.exe, which is an interesting thing, but it doesn't seem to be at the same path. Oh yeah, and another thing that we can do is we can just add the .exe extension right here just to make sure that we do get exes that we're looking for. So the best matches right here is obviously 11111.exe that we already found. And again, you can see a lot of results. So one of the things that I've done is I actually connected the exe with our path, and I just put the star right here to mean anything. So match anything that ends with exe and is in this directory. And now we're going to be able to find by source image all the results that could be interesting for us. So if I press source image right here, I'm going to be able to see all sorts of results. And as you can see, these are some hostwin.exe, and they seem to be in temp, but they also seem to be in some other directories. So that's not what we're looking for. And we can actually take a look at what else do we have right here. And the only thing that I see right here is the build.exe. Now I know for a fact that build.exe is incorrect, and it could be just any other exe that is not malicious. Oh yeah, and one of the things that I had to do is I had to fix the name to finance01, which I had found right here. You can see it on the other ones, and you can also see, if I take a look at user, you can see that it's actually desktop something finance01. So what I did is I just searched that, and now the results should be a bit more accurate. And also this is hinted by tryhackme. It's in the hints, so it's something to keep in mind. And as you can see, we have build.exe and updatewin.exe, and we have the ionic large. So this to me looks like something suspicious. I mean, this looks suspicious as well, but this stands out. So considering the challenge, it is easier to assume that this is actually what we're looking for. So if I take a look at this ionic large.exe, we can see right here that it ran a DNS query as well. There is iplis.ru, so it's a Russian domain. What I want to do first is I want to sort the events by this image. So if I press image and we can press ionic large, obviously delete what we were searching for before. It's going to be the same now. And right here, we're going to find a lot of results. And we're going to take a look at the original name of the file. And since the question is original file name, we can just write original. Original file name looks to be a parameter. So we actually found the results for this. And as you can see, well, we have this URL mon.dll, but it doesn't look like that's what we're looking for. We have this palette explorer.exe, and this is actually the answer. Once you enter the full view, you can see that it's actually ionic large. So what we're looking for right now is the network connections to the IP address that tryhackme asked us. So the first thing that comes to my mind is, so we're just going to go ahead and just press back to where we were, and we're going to see what the operations were for these EXEs. Okay, after reading a little bit, we noticed this IP as before, nothing special. So this is not the result. Anything, it could be even Windows or something. It is maybe masquerading as some Windows service. So let's keep going. Instead of just watching all of this manually, you can actually pick the destination IP thing, and you can notice that there's two IPs that are represented the most, since they said that it was connected 2 times, as it says right here. So 2 outbound connections, we're going to assume that this is the IP. And if I copy this IP, it's actually going to be the same IP. The only thing I want to do is I want to defang the IP. This means we want to just put these braces or brackets, I don't know what they're called, just to make sure that it doesn't get detected by any systems and that it's safer. So you would put this on a phishing URL or something if you don't want the person to get phished accidentally. So anyways, the same binary made some changes to a registry key. What is the key path? We can actually search for the keyword registry or something. If I do this, I'm going to get 11 results. So this is not huge. We can actually look through this and you can see that there's some changes to the registry and there's HKLM, but we're looking for something specific. What was the key path? So it looks like it's asking us for the path only. Well, maybe this is not the line that we're looking for. I think this might be the line that we're looking for. So this is the target object. Let's take a look at the other ones. Yeah, it looks like the same one, but it's a different key. And yeah, that is the same one again. So I'm going to go ahead and assume that this is the path. So defender and real-time protection. And as you can see, it was. Also, another thing to mention is it's in the image field. And if I take a look right here, so this means that this exe has actually changed all these keys. Now it depends on what it did to them, but it doesn't really matter for this case because we figured out what the solution was. So some processes were killed and the associated binaries were deleted. What were the name of the 2 binaries? So right here we're getting into the usage of some Windows functions, and if I press the hint right here, it's going to say task kill. So task kill was used to kill these processes, and I'm going to go ahead and assume that I don't really need this anymore. So I'm going to just search for task kill. And if I do that, we have only 12 events. And let's take a look at what processes were killed. And as you can see, the binaries were deleted as well. So this means it's probably done in the same thing. And as you can see, the same command seems to have deleted this binary right here, phc. And as you can see right here, it is right here. And it looks like there's going to be another command like this. And right here, we have the same one. So this is not the one. And maybe we should extend the results to see if we can find anything. There we go. That's the other exe as well. So these are the exes that were also deleted. The attacker also ran several commands within PowerShell session to change the behavior of Windows Defender. What was the last command executed in the series of similar commands? For this, it took me a second because I couldn't remember the WMIC, and also this function is very long. What I searched for initially was PowerShell, obviously, and maybe Defender or something, but the last command issue has the most recent timestamp. That was a good hint because what was the last command executed in the series of similar commands? So what you can do is you can just look for PowerShell and Defender, and we have only 29 results, and that's completely manageable, so we can just go ahead and use this. And as you can see right here, it says image loaded and everything, and here's our first parent command line, and it looks to be at 109.45, and this is 109.42. So we're looking for the latest one, so this is the one. This is the latest command. So I'm just going to copy this, and this is basically what we're going to paste right here. And as you can see, PowerShell WMIC namespace root, and that works. worked. And after that, we're going to take a look at this question. Now, this was a little bit confusing for me because of the order of the execution, but based on the previous answer, what were the 4 IDs set by the attacker? So based on the previous answer for this specific command, we're going to have to take a look at 4 IDs that are set by the attacker. So after a little bit of an investigation, it looks like it's actually just one long command. And as you can see right here, we have the thread ID default action ID. So this is something interesting because we have, let me see how much of these. So we're going to highlight all of these and let me just see how much of those we have. 6 and some number as well, 2147. And I can also search for ID. So let's see if that works. Let's actually keep the WMIC. And I'm gonna go ahead and copy this, and we're gonna have 17 right now, and we have all sorts of IDs, and there's a huge command line right here, and we can see some IDs right here. So I think this might be it. So as you can see, there's a 2147 right here and it ends in 03, and there's a 2147 right here ends in 007. So all you have to do right here is copy from this command the order in which they're going, and as you can see, this is going to be the order, and that's your solution. And there was another malicious binary executed on the infected system workstation from another app data location, and what is the full path to the binary? So we can remember that we needed to use the full name. There we go, app data, and we're going to take a look at what other file was there used that is suspicious. And for me, if I go to images right here, you're going to see PowerShell, and obviously easycalc.exe. That sounds suspicious. I'm going to click on it, and that's basically the one. You can just copy the path right here, and that's your solution. And what were the DLLs that were loaded from the binary from the previous question and entered the answers in alphabetical order? So we have to see what easycalc has loaded, and if we specified easycalc right here, and we can remove this, we don't really need this, and the PowerShell, it just kind of stayed from the last question, so we can just sort this. And right now we're going to see all the interactions events with easycalc.exe. I'm just going to write DLL as well, just to eliminate all the events that don't include DLL. And as you can see, we have a lot of DLL side loading, and I'm going to go ahead and see if we can see the image loaded field right here, image loaded, and there is the NWELF, FFmpeg, NWDLL, and stuff like that. And we just enter these 3 DLLs, and that's basically it. All of the other ones seem to be referring to something else, so that's it. This is the first room done, and we're going to switch over to another challenge, start the machine, and I'm gonna have to open obviously a new instance of Splunk. Okay, so there we go, we've navigated to another Splunk instance. Okay, we didn't have to log in, that's awesome. If I search main right here, and I can also add another thing, source type, and for source type we can add sysmon operational or event log application and stuff, and I can add sysmon operational for now because sysmon has a lot of results. So let's press alt time and see all the events, and as you can see we have only 2000. So let's take a look at the first question. Okay, the first question is, can you identify the ransomware? And the hint says look for a common Windows binary located in an unusual location. So we're gonna look for an exe, and we're going to see if there's anything weird on an unusual location. This is a Microsoft Exchange server thing. It doesn't seem to be anything weird. Windows Defender on the right location looks fine, and these are all images. So as you remember from before, we can just press image and see what we have right here. We have the compa tel runner. I don't know what this is, but it seems to be on the right location. We're looking for something on a wrong location. So we have a forwarder here for Splunk, but we're going to ignore that. This is just for the challenge. And we can also click rare values. That's going to be interesting, and you can take a look at statistics right here, and let's see if there's anything suspicious in only one of the entries. And we can limit, put like 50. Now we have a few pages, and this is again a system32, and there we go. Documents CMD. So from what I remember, in documents there shouldn't be a cmd.exe, and also administrator user. So we're going to paste it right here. And what sysmon event ID is related to the file creation event. For this you just have to Google, and it's going to say that it's 11. So can you find the MD5 hashes on the ransomware? If I take a look at the cmd.exe, and I can try to search all of those, or you can just simplify your life and just say MD5. And as you can see right here, we're going to find the MD5, so 290, and that is the one. And then what file was saved to multiple folder locations. For this, we're going to have to investigate above this file. So we're going to have to just say index main, and file saved means file created. So we're going to say sysmon event ID is going to be 11. So let's add this to search, and it's going to say event code, and we're just going to say 11. And there's 104 events, but we don't have to look into all of those. Why? Well, because we can just press on the image, and we can see the image that is running it, and we see the clean machine manager, the service host, and our cmd.exe. We're going to filter by the cmd.exe, and after that we're going to click on target file name, and as you can see on target file name we have the readme.txt, readme.txt, readme.txt. So this is the ransom node. We're going to just write that down. It is the solution to this task. So what is the command that the attacker used to add a new user to the compromised system? So for adding users in Windows, you can just Google this. It is netuser/add. You can just search for netuser and you're still going to find the results. So I'm going to keep cmd.exe and I'm going to say netuser, and also I'm going to remove the event code 11 because that's going to confuse everything. And let's see if we find anything, and we do find something, but it is not what we're looking for because it found .NET and stuff like that. So for this we're going to have to remove the image because it looks like the attacker used something else for netuser. And if we look into netuser add, we're going to immediately find a solution. So as you can see right here, it actually says net.exe, net local group remote desktop user, security ninja add. So it's adding it to group administrators, and it's not creating it there, it's creating it here. Net user add security ninja hard to hack 123 and a $sign, and that's it. The attacker migrated the process for better persistence. What is the migrated process image? Executable. And what is the original process image? So this means basically you can read this as process as executable. That's why there's hints here, and when the attacker got on the system. So for this, we need to see how they got persistence. So we can look for the sysmon event code for migrated process image. So for this, sysmon event code 8 actually calls create remote thread. This actually is what we're looking for because it's actually used in migration, and this is actually used in malware analysis as well. If I remember correctly, this belongs to a DLL within Windows. So this is process injection, remote thread injection, and stuff like that. Anyway, doesn't really matter. What we have to look for is sysmon event code 8. So we're going to pick any of these. I don't know if we have anything here. Event code 1. Yeah, sure. Let's pick this and let's just rename this to 8. And we can remove our net user add. And if I take a look at event code 8, we only have 2 results, and you can see that we're using LSASS, and we're also using unsec app as well as PowerShell. So this is probably the initial one because it's older, and PowerShell is used to actually migrate it into unsec app.exe. So there we go. We're going to write that down as well, and we're going to move on to the next question. The attacker also retrieves system hashes. What is the process image used for getting the system hashes? Now, if you remember right here, we actually saw LSASS. So with enough Googling, you would actually find this, but you just kind of have to know this. If you Google LSASS, it makes sense, but if you Google where can you get hashes, it doesn't make much sense. So you kind of just have to know this. I mean, this is for getting system hashes. Try event code 8 and check the target image. So this is actually hinting us the solution because there's only 2 events. There's not much else to be, so it's definitely LSASS. So anyways, we can move on. What is the web shell, the exploit deployed to the system? So we're talking about a web shell for Windows. Now this could be basically anything, but the common thing for Windows is actually ASP. So I'm going to write down .asp and see if we can find any matches, and we did find 47 matches, which is not hard to look into, and it's mostly Microsoft's content redirect something. Then we're going to take a look at ASPX because that is usually what the shells are created for, and there is a few scripts right here, but what we're looking for is the web shell, web maybe. Let's see if that works. And this looks like some kind of an error, web event, and it says, yeah, there we go. See, the process cannot access the file because it's being used by another process, and there is a file IO stream in it, and it looks like it's web, and there's a requested path, and I'm gonna go ahead and assume that that's the one, and considering it's in auth as well, it might as well be, and as you can see, it really is. So this was actually really easy. We were kind of lucky to find it right here, considering we just kind of looked for web and ASPX. Alternatively, this could be a PHP script or something. A lot of things could work. A PHP reverse shell is probably the most often one though, so that's something to keep in mind. So what is the command line executed for this web shell? Because we know the name of the web shell, we're just going to copy it, and we're just going to remove everything and just paste it right here. It looks like that's the only command, and it says command line or attrib. It's basically like chmod on Linux. What 3 CVEs did this exploit leverage? If you remember from before, we actually have one step back. So here is our hint: Microsoft Exchange server version 15 front-end HTTP proxy auth. So this could be something. If I copy this right here, the first match is a 0-day exploit. So let's take a look at that, and you can see right here that there's some CVEs. There is a remote code execution and server-side request forgery. So this could be it, but we're going to have to verify. The hint says just external search is required, and we can actually search for Conti ransomware. And let's take a look at what we can find. Okay, after a lot of investigation, because at first I kept finding the 2021 results, I found the CVs that we're talking about. And there is a list right here. And most importantly, this Twitter post right here actually points out what we're looking for. So two 2018 ones, 1337 and 2020-07. So 1337, 1337 and 07 on 2020. So that's it. That is the correct answer. And that would be all. This was just a quick little reminder of how to use Splunk, because I haven't used it in a while. So I thought to myself, I'm going to make a video about it. I'm sorry I haven't been posting in some time. I don't have any ideas that I'm really excited about. I do like reversing and malware analysis, and I want to do more videos on that, but I do have to think of a perfect enough topic to cover in a video and a wide enough topic to cover in a video, because I want the videos to be covering wide topics. So anyways, thank you so much for watching and have a nice day.